But mainly we're going to just show you some chemistry, which is like science. Who knows what chemistry is even? Have you heard of it before? Shannon, I hope you do. You've heard of it? Well, who can tell me what you think it is? Go ahead.
I think that's like a lot of science.
It's a lot of science, exactly. What do you think? It's about chemicals, right? That makes sense. Chemistry is about chemicals. We'll just take one more. Go ahead.
Blowing up stuff.
That's about blowing up stuff. That's what we're talking about.
Yes.
Okay. So I'm gonna show you a chemical reaction on the board, and then we'll watch it happen. How's that? So then we'll know that we're doing chemistry because there's like some chemistry stuff that we'll write down first. But this is it. My writing is definitely better than Mr. Peck's and Carey. That's one thing for sure. I wish I didn't have that stuff there. But guess what we're going to do? We're going to make water. And we're going to make that out of, who knows what that is? That's water. This is?
Hydrogen.
Hydrogen, and that is?
Oxygen.
Oxygen is water is made out of hydrogen and oxygen. And if I was going to be careful, then I'd have to balance my chemical equation. So that's what a chemical equation looks like. Where you have some type of chemicals over here, you have an arrow, which means it's going to that, and then you have some other type of chemicals over there. Okay? The way this is going to work is, those are both gases, and so it's kind of hard to keep track of gases. They're just going everywhere and stuff. But so what I did is I put hydrogen inside the balloon. And then there's oxygen all around us. We breathe oxygen all the time. So oxygen can bump into the hydrogen if we just like pop the balloon, then they'll touch each other. With this, to actually get the reaction going, we kind of need a little bit of a spark. So what I'm going to do is, where I can touch this little bit of fire to the balloon is get this candle burning, maybe. That's a bad match. And then, if you want to get the lights once. So we'll see how this reaction looks. And it's kind of, that's good. It's more fun to watch it in the dark. So let's just see if I touch the flame valve. You're right. It's about blowing stuff up. Is we blew up a hydrogen balloon just because of this chemical reaction. So chemists, they're interested in stuff because it's cool if something blows up. That's true. But they're also interested in that because that gave off a lot of
Oxygen.
No, it gave off water. And you can't really see the water because it wasn't too much. It's like in steam in the air now, gas in the air. But also, did you notice anything? What'd you see?
Fire.
It was fire. It gave off light, didn't it? Did you feel anything if you were up here? Did you? What'd you feel? It got hot. You guys felt the heat. And then even the air kind of rushed past you. So that tells us that when these chemicals change, there's also, what? I heard it over here. Maybe I just made up, I heard. Release of energy, wasn't it? So chemists are also interested in how you can get energy from matter or from chemicals. And so that's kind of fun, but also, in reality, it's kind of useful because people are trying to figure out, and they already have in a lot of ways, how to take this reaction, which is kind of nice because it just makes water and nobody worries about having water laying around, which is kind of handy. And also gives you a lot of energy. So that's one way that you might be able to fuel your car instead of having gas in it or other things like that. All right, what other kind of if you understand chemistry, you kind of have control over some of those colors and kind of can play around with them a little bit. So if you look at this, what would you say that looks like? Looks like water. It's clear, right? It's clear and it's colorless, just like water is. Know why that is? Because it's water, correct. So your chemists are right. Watch what happens if I put in one drop of this. I'm hoping for one drop. Sometimes it's more than one drop. And so then I can get, what color is that?
Purple.
What if you drink it? How many of you are colorblind?
I don't know what it is, but it's pretty.
It's pretty.
I think it's fuchsia. What if I put in a couple drops of that?
Turn it back to clear.
Didn't quite make it, did it? It's still a little bit, I don't know if you can see that there. One more drop, I bet. I can get it back.
Was it water? Can you drink it?
Yeah. But it's not a good idea to drink it, right? So this is lithium chloride. So this has lithium, this has copper, this one has potassium, this one has sodium, that one has barium. Those are all examples of
Air.
different, what?
Gases.
They're not gases.
Chemicals.
They're all elements, aren't they? And if you know about the periodic table, that Shendon's sitting by, those are all elements that show up on the periodic table. And they all have different types of properties, and one of the properties is what color of light they give off when they get hot. So what I'm going to do, you can never have too much fire.
Wait, burning.
Okay, so they're burning.
One of them's burning.
Yeah, they're burning.
2, 3.
Let's see what they look like if we turn the lights on. So what do you notice? That's exactly what we noticed in great detail. So over here, let me just, so think about this. You hear about chemicals all the time, or elements. The one that's over here on my right, your left, is lithium. The one that burns kind of green is copper. You sort of have that lavender color from potassium. Sodium is the one that's really kind of a bright yellow. That's really distinct. And then the sort of lemonish, or I'm not sure what kind of greenish yellow, is the barium. I want you to think when you might have seen something like this before. Go ahead.
Because I've seen the powder go into the fire and then it just changes. Kind of like that thing you just did.
Sounded kind of like that. Anybody else? Go
What?
ahead.
I saw a big fire before because my dad started burning a lot of wood and then it got really hot.
Okay, blue fire.
It's evil.
Anybody been to a celebration on the 4th of July? What do you say? Fireworks. That's how they make fireworks, isn't it? Why do you get the different colors when you see a firework go off? It's because they put in different chemicals. Different elements will give you the different colors. And so they put the combinations that they think are going to be pretty. And then when it explodes with the gunpowder and things, that makes it hot enough, then you get to see those colors. That's one reason why chemists like it, because they like to make fireworks. Right?
So it works. How it works is they take this stuff and they put all the different chemicals in it, and then they decorate it and make sure there's a hole in the bottom that can fit a rope through, and then they light the rope on fire, and then it completely the fire goes down the rope into the hole and explodes. Okay, I
And
really
then
want to put
you
that
have a
in.
firework. What question can I answer? This is what you got to do. You got to grow up, go to BYU Idaho, become a chemistry major, and then you do it every day.
Just below.
Or you go to Boise State, or to Idaho State, or wherever you want to go to college. So then become a chemist, and then you're set. And that would be awesome. I went to the University of Utah, but I started here. Okay, so who knows about liquid nitrogen? What do you know about it? Liquid nitrogen is really cold. It's true. And so just, like I said, this is minus 200 degrees Celsius. So that's really cold. Water boils at 0 degrees Celsius. So it gets a lot colder than that. What I'm going to try to do is see if I can get this flask cold enough that some of the liquid nitrogen will stay in it. this will just give you an idea. Now it's boiling. And so it's turning to a gas.
Oh, I didn't fire.
And just look at how this works. See how most of the liquid nitrogen is still there? Down there? But even though the liquid nitrogen is mostly still down there, a little bit of it is boiled, look how big the balloon has gotten. What does that actually tell you about liquids and gases? In the liquid, in the liquid, all the molecules are. What are you so worried about? In the liquid, the molecules are really close together, right? But in the gas, they're really far apart. So when they're gas, they take up a lot more space than when they're in the liquid. See, most of the liquid nitrogen is still there. Another thing you'll notice how this is all frosty. Why is that? That's because water, just from the air, even, was so cold it got there and stuck. Just like on your windshield on a cold morning in Carey. That's the deal. And the whole, that's pretty big. Huh? You know when you're blowing up the balloon and your mom says, "Oh, don't blow it too much. It's gonna pop."
Yeah.
You gotta blow it quite a bit before it pops. And these are just regular rules. But think of that. See how the liquid nitrogen is. The liquid nitrogen is still that deep. It's still that deep. But the balloon was huge, right? It doesn't take very much liquid to turn into a gas to make.
It's pushing back
Yeah, we better hustle, huh? Looks like it's time for you to go, so we'll see how much. We might get some other chemical reactions here, so I don't really know exactly how this is going to work, but.
Maybe it's going to explode. Dude, it might kill it all. Let's see.
Okay, this is what you wanted, right? We'll see what happens. It's probably a really bad idea. What should we see before we turn off the lights? What should it look like? It should look like a mixture of all these. What we're actually going to see is one thing's probably stronger than all the others.
White. Sodium.
That's usually what you find. You can kind of see the other colors mixed in. And they
I can see the green.
There's a little green streak, and you can see the potassium a little bit. But when you mix them all together, the one that usually wins, you can see the most, is sodium.
What's the hottest fire in the world?
Hottest fire in the world? I'm not sure.
White?
Maybe the sun.
Yeah, that's how fire. The sun is actually lava.
Well,